What's up everyone, Patrick here, welcome back. In this next video, what we're gonna do is we're gonna take these 8 equations here and we're gonna isolate for the x in them. So notice all these equations contain x, it's just we're gonna have to isolate for it. So this is gonna be good practice in terms of algebraic skills. Notice how there's so many different formats here. So there's different ways, different processes we're gonna go through. So for now, I'm gonna erase 5 to 8. I'll bring them back later on in the video. So let's start with number 1. This is v is equal to x, y, z. And we have to isolate for this x. Notice everything is multiplying here. And so if we want to isolate for that x, what we would do is we would just divide this side by yz, divide this side by yz, and then notice these cancel out. So now the x would be by itself and it would equal v over yz. Another way you could write it is x equals v over yz, like that. Right, so isolating for x in the first one, that's what you get right there. Now number 2, this one's going to be a little bit more tricky, more work here. So notice we got 1 over x equals 1 over a plus 1 over b. What would we do here? Well, it would be nice if this right side was one fraction, because then we could just flip the fraction. So for example, if we have 1 over x, let's use different letters here. Let's say we had 1 over x equals m over n. Well, that would just mean we could flip, notice how there's one fraction on each side, so we could flip this fraction, flip this one, so we'd end up with x over 1, which is just x, equals n over m, like that. Right? And you could see this result too, if you cross multiply it at this point, we'd have mx equals n, x equals n over m. But in this case, we can't cross multiply at this point because there's 2 fractions here. Remember, to cross multiply, there's got to be one fraction on each side. And so what we could do is we could take this right side and combine it into one fraction. How would we do that? We would need a common denominator because we're adding fractions, so we'd multiply by b, multiply by b, multiply this by a, multiply this by a. And we'd end up with b plus a over ab. Or if you want to write it maybe in a nicer format, so these are in alphabetical order, a plus b over ab. Both of these are the same. And now we have one fraction here, and so basically x would just be this fraction flipped over, like that. Or if you wanted to cross multiply, so 1 times ab is ab, and then we'd have x times a plus b, you got to put that in brackets, then divide both sides by a plus b. That cancels out, we get the x by itself, and we get to that result right there. You can't cross multiply at this point here because there's 2 separate fractions. Okay, if you were to cross multiply at this point, what would happen is you'd have to go 1 over x equals, basically, you'd have to look at this as one expression over 1. And then you could cross multiply at this point, and then you'd end up x equals 1 over 1 plus a plus 1 over a plus 1 over b. Right? And then that would end up simplifying to what we got before. But I feel like that's a little bit more work to go through that process. It's easier to just put this as one fraction and then flip it to isolate for that x. Now moving on to number 3, we got m equals y minus x over a minus b. So over here, notice that that x is fairly within the function, but what we can do here, notice this is m over 1, this is one fraction, we could cross multiply at this point. So 1 times y minus x is just y minus x, and then we'll have m times a minus b. And then from here, notice, really easy to isolate for this x. We could just bring it over, bring this over, so we'd end up with y minus m bracket a minus b is equal to x. We don't change this sign. This is like one expression here, and there's like a positive in front, so when we bring it over, the whole expression stays the same, but that changes into a minus, then the negative x changes to positive x. So that's what the answer would be here. If you want to maybe expand this, that could be the answer like that as well. Both of these are the same thing. The x is isolated for. In number 4, we have a equals b times 1 plus rx. So again, the x is fairly within the function here. Now, a couple of things you could do here. You can distribute the b if you want. So let's do this a couple of ways, just to show you different ways this can happen. So if we distribute the b inside here, we'd end up with this. Bring this b over, so we'd end up with a minus b equals brx, then divide both sides by br. So these cancel out, and so x would end up equaling a minus b over br. So that's one way. Another way you could have done it is you could have divided both sides by b at this point, because these two are multiplying, these two expressions. So we'd end up with a over b equals 1 plus rx, like that. And then we'd have a over b minus 1 is equal to rx, like that. And then divide everything by r at this point. I don't really like this way too much, because you'd have to divide this by r, and then it just starts getting a little bit more complex with this. Basically, you'd have a over b divided by r, which is like dividing by r over 1, so it'd be like a over b times 1 over r, which would be a over br. And so you'd end up with a over br minus 1 over r, like that. And this and this, they're the exact same thing. If you wanted to go from here to here, which I feel like would be easier, what you could do is you could just split this fraction up. You could go a over br minus b over br, right? Split this into two fractions. Nothing simplifies here, but notice here the b's cancel out, and so you'd end up with that 1 over r that you had there. Right, so this and this are the same thing. You got to be careful. Maybe if this is a multiple choice question, one of these formats can be there. So you got to be able to go from here to here or from here to here. If you wanted to go from here to here, you'd have to combine these into one fraction. So there have to be a common denominator. So you'd multiply this by b, multiply this by b. Common denominator would be br, and then you'd end up with a minus that b in the numerator. Right, so just be careful with these different formats. Now moving on to number 5, we got f equals x times 1 plus r to the power n minus 1 all over r. Now this here is actually a time value equation. It's the future value of an annuity, but we're more so going to focus on the math, the algebraic part in this video. So we got to isolate for this x here. So we got x times this entire expression. So notice that we can actually, what we can do here is we can just divide both sides by that entire expression. So if we rewrite this, so we'll have 1 plus r to the power n minus 1 all over r. We could divide by this entire bracket and divide here by that entire bracket. Right, so this would be dividing by 1 plus r to the power n minus 1 over r, and then these brackets are the same, so notice they cancel out. So notice we'd end up with x equals f. This f is like over 1, so we'd have f over 1 divided by, this is like a fraction here, so we're dividing by 1 plus r to the power n minus 1 all over r, like that. And so here, what we could do, what do we do when we divide fractions? Well, we flip this second one, and then we'd be multiplying. Like that. And then you could just combine these, f times r all over 1 plus r to the power of n minus 1, like that. Right, so x equals this over here, and you can't simplify that any further. Right, so it's just recognizing that this is a fraction here, dividing both sides by that fraction. So then you got to flip the fraction, then you could combine this term from the left side and that fraction into one fraction. Another way this could have been, I'm just realizing maybe I could have shown it this way, is another way this could have been shown is this r could have been under this x here. So we'd have x over r. And then we'd have 1 plus r to the power of n minus 1, like that. So that's another way. And then different ways you can go about it here. You can take this over r and then shift it to here because you're multiplying these two. So like a over x times b is the same as a times b over x, right? You could shift that denominator to any of these because you're multiplying there. So same thing here. We could take that r, put it here, follow that exact same process. Or another thing you could do is just from here, isolate in steps. So what we would do, we would multiply this side by r, multiply this side by r, then these would cancel out, and then you'd have x times this expression, then you would divide by that expression. Then you divide this side by that expression. That's the same answer that we got before, and then the x would be isolated. Right, so that's how it would, that's how you can go about it if it was given in that other format. Now, number 6, we have a equals 3 over 5 times x minus 2. So the x is here. A couple of things we could do. We can distribute. What I'm going to do is I'm actually going to divide both sides by 3 over 5 at this point instead of distributing. So we'd have a over 1 divided by 3 over 5, which would be like a over 1 times 5 over 3, which would be like 5a over 3. So that's what that left side would end up being. So we'd have 5a over 3, or 5 over 3a, both are the same thing, equals x minus 2, and then bring the negative 2 over. Pretty simple, like that. And then if you did it the other way, if you distributed the 3 over 5, again, you'd get the same answer. Right? If we take the 3 over 5, multiply by these two, bring this over, so we'd have a plus 6 over 5 equals 3 over 5x. But then you'd have to divide everything by 3 over 5. This by 3 over 5, and this by 3 over 5. We know this already is 5a over 3. And then 6 over 5 divided by 3 over 5 would be like multiplying by 5 over 3. Notice the 5's cancel out. 6 over 3 ends up being 2. So we end up with that same solution there. Another format this could be in, they could combine these into one fraction. So this is like over 1. So you'd multiply this by 3, multiply this by 3. And so this can also be shown as 5a plus 6 all over 3, like that. That's another way this can be done. Right, so just be careful because you may get to this point, but the answer may be like this. In this format, you got to be able to check whether that answer is going to be the same. Right, so whichever way you do it, that's how you isolate for x in number 6. And then number 7, this is actually a pretty common one, especially in, this starts being common in like grade 11, this kind of question. Students a lot of times get stuck on it. When you're like finding the inverse of a function, remember when you got to like switch the x and y and then isolate for the y? So there'd be like 2 y's over here, but in this case we're just isolating for the x, so it's the same thing, it's just the letters are switched. So here, what we would do, there's two x's here, so you got to cross multiply. So you'd end up with y times 2x minus 5 equals 1 times x plus 4. And so from here, what you want to do is you got to expand everything, and then you got to bring all the terms that have an x attached to them to one side, and then all the other terms to the other side. So this would end up being 2xy minus 5y equals x plus 4. Right? We distribute the y. Now notice this term has an x and this term has an x. So I'm going to bring this over and then bring that over. So we'd have 2xy minus x equals 5y plus 4. Right? This turns into a positive 5y. And then from here, once you have all the terms that have an x attached to them on one side, you want to take out that x. Factor it out like that. So now we have 1x. So we just took this and put it in a format where we only have 1x to deal with, and you would divide both sides by 2y minus 1, divide this by 2y minus 1, and that would be the answer. So x would end up equaling 5y plus 4 over 2y minus 1, like that. Right? So just be careful with these kinds where there's multiple x's in a fraction. You cross multiply, bring all the x's, all the terms that have x's attached to them to one side, factor out that x, and then you can isolate for that x by itself. All right, so that's the answer to number 7. And then finally, number 8. We'd have m equals 3ax plus by plus bx. Like this. We can divide both sides by 3 to get rid of this 3. But then that's going to make it a little more complex, because then we're going to have to divide. We're going to have to factor out this x from these two, and then we're going to have to divide that by that a plus b. So we'd have a fraction dividing by another term. It's just going to make things more complex. So in this case, I think it's easier to just distribute the 3 inside the bracket, bring the by over, right, keeping all the values that have an x attached to them on one side, take out that x, and then divide both sides by that bracket. And so we'd end up with x equaling m minus 3by all over 3a plus 3b. That would be the answer. That's how you would isolate for the x. So kind of similar to the question 7, this part over here, where you got to keep all the terms with an x on one side, factor out that x, then divide both sides by that bracket. But yeah, that's how you go about it. All right, so just a couple of different formats you can run into when you're isolating for x.